Thank you for attending this GNF on Mars and Moon analogues. We have joined together in this discussion people coming from different experience from Moon and Mars simulation in order to put together some knowledge also in view of future cooperation. We are Mars Planet, Italian chapter of the Mars Society, and we make this kind of studies with people around the world to investigate how analogues could be used for the simulation of human exploration of space. Now we are in a short schedule, so I give the words to Robert Zubrin as a first introduction to this topic.
Hello, I'm Robert Zubrin. I'm president of the Mars Society, also of a small aerospace company, Pioneer Astronautics. And I would also be remiss if I didn't mention that I was an author. I wrote a book called The Case for Mars, which you may be familiar with, and most recently I have a new book called The Case for Space, which you should read. Can I have my charts?
Maybe you press this and you skip this presentation, maybe? Go, maybe.
Can they load my charts?
Yeah, maybe after this, we try. One more?
No, I'm at the end of Antonio's. It's a different presentation. Okay, well, the Mars Society was founded in 1998. We resolved to do three things. One was broad outreach to spread the vision. Second, political work to defend the Mars programs in the political realm. And the third is projects of our own, of which we decided that the most important thing we could do within the kind of budgets we could reasonably arrange would be to create a Mars analog research station. You know, I'd been at Martin Marietta in the 80s, and we had proposed to NASA to build a Mars analog research station. They liked it, but they couldn't get the budget from Congress. Mars Society thought we could actually raise the money, and somehow we did. Can I have, you had a chart of mine. Okay, anyway, we had heard about a place in the high Arctic called Devon Island, where NASA had identified, it was a polar desert with a meteor impact crater in it that had created geology. Yes, these charts, thank you. Similar to Mars, and we decided to build an analog station there. And how does one, can I advance the charts, please? Okay, stop there, thank you. Okay. This is the Flashline Mars Arctic Research Station on Devon Island. It's on the rim of a 20-kilometer meteor impact crater, Mars-like geology, but the terrain's actually very interesting geologically. There's also Devonian fossils there. And this creates a huge theater of operations for studies of exploration. That is, our analog program is not an isolation program. It is an exploration research program, okay, in which we try to figure out what modes of operation would work best on Mars, what method of organizing the crew, what kind of technologies would be most useful, for example, field mobility. Do you want large pressurized rovers the size of school buses with laboratory facilities, or smaller ones the size of SUVs? We found most useful equestrian vehicles like all-terrain vehicles. They're far more nimble. They can negotiate rough terrain. If they get stuck, you can pull them out. And once again, if you want to have a good analog, in my view, while isolation studies have their role, the real thing that we need to study is exploration. That's what the Mars mission is about. Okay, so we built this station in the high Arctic, and we've used it about 12 times, only in the summer, because otherwise conditions are much too difficult there, and then during half the year there's even no light. But we decided to build an additional station in the desert, and this is the Mars Desert Research Station in Utah. Now, we've had over 200 crews here of 6 people each. That is, over 1,200 people have been a crew member of this station. And we've had every kind of composition you could imagine. International crews, national crews, mixed gender crews, one gender, the other gender, you know, different age mix, skill mixes, etc. What kind of character types are most useful on Mars? Once again, we find the field mobility technology to be the all-terrain vehicle, either one person or two person. You know, organization, you absolutely do need a crew commander, but you want to have a consultative command style, and many other things. And yes, it's a great place for astronomy too, although that's not so much an activity for Mars, but it's representative of a highly technical activity that the crew would have to do. And I mean, one thing, this is the Arctic, you know, only humans could negotiate this kind of terrain, not rovers. And here's an interesting picture. That's me in actually the first MDRS crew. And I want to tell this story because on our first motorized excursion, we had a number of pedestrian EVAs, and then our first motorized excursion, we traveled about 5 kilometers to the north of the Hab, and then we saw this little hill that we thought we could climb, and we did, and from there we had a view, and from there we saw this interesting little hidden canyon, and we thought, well, let's go over there. And there was about a 2-meter drop into the canyon, but we could climb it even with these awkward spacesuits, which, by the way, were designed to be awkward. They were designed to create some of the difficulties that an actual spacesuit would impose on astronauts attempting to explore. But we were able to get down to this little box canyon, and we're exploring around, and you know, you're walking around, and you're taking the equivalent of millions of high-definition pictures with your eyes, and then all of a sudden something catches your eye. You go over there, you reach down, you pick up the rock. No, this is nothing special. Throw it away, et cetera, et cetera. And finally, I saw this rather odd rock, and I picked it up and dusted it off, and it indeed looked very strange. So I called over Jen Heldman, who was a geologist, and she's now at NASA. Then she was a grad student. And what's this? And she said, this looks like fossilized bone. And we took it back to the Hab, and we thin-sectioned it, and indeed it was dinosaur bone. And we reported that to the Bureau of Land Management along with the GPS coordinates of that site. And about 6 years later, some professional paleontologists from the Burpee Museum in Illinois contacted BLM and said, anybody found any dinosaur fossils around there? And they said, yeah, the Mars people found one. Here's the coordinates. So professional paleontologists went over there and dug the place up, and it has turned out to be a gigantic trove of dinosaur fossils. It's like one of these places in Africa where all the bones accumulate in a bend in a river. They say, actually, this is the largest find of dinosaur fossils in the world in the past several decades. And the point I'm making is this, is only human explorers could have found this. Only human explorers could have climbed that little hill. Only human explorers could have gotten into that little canyon, only because it's a 2-meter drop, no wheeled vehicle could do it. And then just finding this thing, just the amount of data you had to sort of sift through with your eyes, and then a lot of follow-up that didn't amount to anything, and then finally follow-up that did, and then taking it back to the Hab and thin-sectioning it. Once again, task for human explorers. And I think this is a model for why we need humans on Mars. Okay, you know, one of the first things we want to do on Mars is fossil hunting. It requires a lot of trekking through unimproved terrain, hiking, heavy work, pickaxe work, delicate work, thin sectioning things. These things are far beyond the ability of robotic rovers. So you know, we've been exploring exploration, and you know, a lot of people have come and they've gone back to their home institutions carrying insights that they've gained from this experience, so that's really great. A lot of them have gone on to found additional stations in Hawaii, in Poland, in Israel, and the Austrian Space Forum, which does it in a variety of locations every 2 years, and there's talk now of possibly one in Russia as well. You know, I think, you know, we're not training the first astronauts. I mean, it's possible that one or another person who's in one of our crews may someday be an astronaut, but That's not, we're trying to write the book of tactics. We're trying to give some insight into what the field manual should be. And providing people with some insight and creating a new discipline of Mars analog research studies. You know, I liken our habitats, which are relatively crude, to Galileo's telescope. He made some discoveries with those telescopes, but even more, he showed the value of telescopes for astronomy. And so that after him, much better telescopes were built. Herschel's telescope, the Mount Palomar telescope, the Hubble telescope, okay? And it's my hope that the space agencies, NASA, ESA, Roscosmos, with their much larger budgets, will pick up the baton and create better analog stations. Leave us behind as primitive exercises that they can do much better, and let's learn how to explore Mars on Earth. Thank you.
Can I please have the presentation, the second one? Can we please display the second presentation? Thank you.
This year, we not only remember the achievements of 50 years ago, but are planning for the next 50 years on the Moon. A plan called the Moon Village. The Moon Village requires an organization to facilitate its implementation. This is the Moon Village Association. How can the Moon Village Association foster the implementation of the Moon Village? First, by defining its founding principles, and second, by identifying the Moon missions and activities fulfilling these principles. The principles are general, but they embody the spirit and cooperation and inclusiveness of the Moon Village. See them at www.moonvillageassociation.org. The process of constructing the Moon Village started this year, with the first Moon missions and activities identified by the Moon Village Association being acknowledged worldwide. The approach of implementing the Moon Village concept into real missions and activities beyond any national program is paving the way for open, peaceful coordination and cooperation between the stakeholders that will adopt them by building mutual confidence and trust without any formal agreement. This will boost global cooperation like never seen before, creating a sustainable moon market that will create new wealth for its citizens. In a complex and interconnected world, the Moon Village will inspire and bring benefits to the young generation, democratizing access to the Moon. The Moon Village will contribute to achieving the goal for sustainable development on Earth, a requirement included in the UN Agenda 2030, and pave the way for the expansion of humanity beyond Earth. The Moon Village Association will play a unique role thanks to your support.
Ladies and gentlemen, my name is George Danos, and I'm the chair of the Moon Village Association Analogues Working Group. Over the last couple of years, the Moon Village Analog Working Group, with entities and researchers from around the globe, has sought for solutions and synergies in establishing the Moon Village. Working together, we have identified the following challenges that required solutions. Primarily, collaboration, identifying partners and synergies that would lead to an international collaboration, in effect connecting infrastructure, research and technologies, institutional, business, and academic. 2, access and storing of know-how, a repository of solutions and knowledge. 3, availability of facilities for testing. And some considerations here is the proximity and access to facilities to test hardware and human factors, but also the development of human factor solutions. And 4, regulations and framework of cooperation and operation. To name just one, issues with dust and the preservation of the Apollo sites. But the list is long, and international cooperation is key to getting these things right. A tighter cooperation was proposed by key partners, and starting with entities and stakeholders from the USA, UK, Europe, and Asia, the Moon Analog Consortium was founded. So we're announcing today the formation of the Moon Analog Consortium. It's a spin-off of the Moon Village Association, an independent organization fostered, supported, and incubated by the Moon Village Association, in close cooperation and synergy with the Moon Village Association, and its aims to foster and facilitate communication and cooperation between the stakeholders, infrastructure, research, technologies, institutional, business, and academic. To facilitate the provision and collaboration, creating of analog facilities, collaborative creation of analog facilities across regions of the globe for ease of access and proximity of use. And to operate online and face-to-face brokering tools and website listings so that the parties who want to know where to find solutions or other people to cooperate with can see who they are. And last but not least, to act as a repository of know-how, technologies, challenges, and solutions, as well as regulatory and framework documents related to the Moon analogues. We have some leaflets with Jan Collard here at the front, so if you want to read more about the Moon Village, please come here and get a leaflet. And if you want to join this consortium, please come and talk to me at the end of this presentation, or simply email your interest at the email address displayed. Thank you very much.
Good morning. My name is Barbara Imhoff. I'm a space architect, and I'm the co-founder and co-managing director of Liquifer Systems Group. And I'd like to show you a couple of projects we were involved in, and which had to do with, or where we developed technology as part of simulations or analog missions. In general, analog missions and simulations have been part of preparing for future exploration since the early 1960s. It's a good way of testing, of anticipating, of reenacting what we think could be out there when we go to explore the lunar surface or the Martian surface. So it's an old, how can I say, it's an established method. And it's also a method or a way of actually having the opportunity with, in very economic means, to test space missions. So that's why we can see a lot of simulators and analog missions sprouting all over the world currently. So this is what you can see here. This was a project, Moonwalk. It was a European framework project, and it was the Mars simulation mission in an established analog site in Rio Tinto in the south of Spain. Project Moonwalk was about testing human robot collaboration, and you see here the three elements of the analog mission. It was the little helper rover, the astronaut, and the habitat. So these were the three main elements. Rio Tinto is also part of an established analog site for Mars missions. There has been ESA has conducted a study, and the outcome is the so-called CAFE study, which identifies, I think, over 30 sites for Moon and Mars analogs all over the world. And it's quite a good, I would say, reference when you look for a specific test opportunity. So what can you test in such analogs? First it starts with preparing all the logistics. The logistics is already part of a space mission. So getting the logistics right is one point. Looking at the operations, how can we ensure that what we want to test, so creating the scenarios that what we want to test is actually then delivering knowledge we want to know. And as part of the Rio Tinto moonwalk missions was also a lot of science, because the Rio Tinto is an old mining site which has a very specific eco-environment. So you can look for extremophiles. So the methodologies you apply for looking for these extremophiles are probably quite similar to a real Mars mission. So that's the interest of this site. Inside the habitat, which was quite unique in 2016 when we put the self-deployable habitat for extreme environments, part of another EU FP7 project, into that mission, we could then conduct further research on the samples. You see on the left-hand side the astrobiology lab we established, and on the right-hand side we had the local mission control on simulated Mars. And you see Diego Urbina as one of the Capcoms, and he's also in the audience. I think so. Maybe not. What we also did is, because we used a suit which had to be operated through a Suitport. A Suitport is a possibility to actually prevent cross-contamination for a Mars mission. When you're looking for life on Mars, you might not want to find your own life you're bringing there. So here you see how these kind of operations could have been looked like when you step from the back into that suit with the Suitport. The suit was developed by COMEX. So this was a lot about developing specific procedures for the Suitport, or for stepping into the suit, and also looking at the technologies. Another option is when you test the moon, for the moon, or you want to find out how it is actually to have lunar operations, is to go underwater. This was also part of Project Moonwalk. Here, especially, what was quite interesting is that one of the safety divers, we had to abort one of the simulations because one of the safety divers got a little bit too claustrophobic. So what you can also, apart from the human-robot interaction, I think underwater simulations give you also a good sense of the isolation or the being captured in the suit. So apart from the 1/6 gravity, you can easily simulate. Another test site where we were involved in is, or still involved in, is the Antarctic, which is actually, I would always say the Antarctic is the closest you can come to space on Earth, because it's really extreme in its climate and very remote and isolated. And we put under the lead of the DLR, the Eden ISS greenhouse here, to see whether or how a greenhouse can support an overwintering mission with fresh fruit and vegetables. So this is especially important for long-duration space flights, where you can really simulate, first of all, through an overwintering mission, long duration, isolation, and it was also about advancing technologies as part of establishing life support, a part of the life support system in a greenhouse. So here you see Paul Zabel of the DLR. He was the DLR. He was the gardener, and this was the kind of sort of jungle type of looking greenhouse where they harvested within 9 months approximately 270 kilograms of fresh vegetables. As a summary, so analog training is very important for preparing future space exploration missions wherever we go with humans, and it has been done throughout the whole, space flight, human space flight endeavors. It's really about selecting the best site for the desired purpose. It's also about looking at, do I want to have an analog mission with directed towards a very specific focus of finding out specific operations, or is it also about science, or is it about multiple events coming together, habitation, robot-human interaction, etc. The other possibility we also have is actually testing, analog testing indoor in controlled environments. This is an advantage to have this controlled environment. So there have been a couple of, there's for example the NASA very old Apollo simulator, which was where we had simulations in 1995 to 1998 in the little lunar Mars test project. Then there was a big simulator planned. I was part of Bioplex, or later named Integrity, and most recent study from ESA for the lunar analog test project, which is will be implemented at the Astronaut Center in Cologne soon. Thank you very much.
Okay, if you can put the fourth presentation. I'm trying to recover the big delay we have. Thanks for staying with us. Well, my name is Maria Antonietta Perino. I work for Thales Alenia Space in Torino, and our best contribution to exploration there is focused on pressurized module. So we truly believe that Moon and Mars offers us the possibility to export the capability we tested and we developed in low Earth orbit, where we in fact contributed to a large part of the pressurized volume of the space station, where people live and work every day. And so our ambition is to export this capability to host the future astronaut in what we call deep space. Now, to get ready to bring people back to the Moon and then onward on Mars, we plan to, as it was agreed by all the major aerospace agencies in the world, we believe that the only way to proceed is according to a multi-step approach. So we are currently fully embarked in the first step, the robotic exploration phase. Our company is leading basically all the European aerospace industries in collaboration with Roscosmos for the ExoMars mission. So back in Torino we have a lot of terrestrial analogues, for example, to prepare the operations that the rover will perform on Mars. And then to move forward to the next step, we are preparing mock-ups of our new habitats. Is really different and more challenging to design a habitat to host people so far away from Earth. It's different both from a technical point of view and from a psychological point of view. Because people that are currently living on board the space station, when they feel the need, they can just go into the cupola and look outside and they feel a psychological connection to our planet because they can recognize the countries, they can recognize rivers, mountains, and so on. When these people will orbit around the moon or when they will be in transit toward Mars, the whole story will be completely different. And so let me share with you some minutes of the modules that we are designing right now. We are exporting, if I may say so, our Italian architectural design capabilities by trying to do our best to offer a more pleasant environment with respect to the current one. So you see that our new habitats have more room. We can use, thanks to the current technology, partitions that are flexible, then can offer a certain area in the day and a different area for crew quarters in the evening. Thanks to the 3D printing capability, we can change the environment along our trip. We will provide area for the exercise. We will use for storage all the volumes under the floor and in the cones. The idea is really, thanks to the Internet of Things opportunity, is to offer each crew member the possibility to set the environmental control, so the temperature, the lighting system, and so on. And I told you that it's not only a psychological need, but there are also many technological plus criticalities, challenges. You are just viewing there the problem of radiation. As soon as we leave Mother Earth, we are no longer protected against radiation, so we are planning to build, for radiation protection, water walls. Privacy will be key, and also the idea is to offer multisensorial capabilities, so viewing with virtual reality, you see the screen, but also sensor, so smelling, sounds, because what we want to offer is to the crew is the feeling that we are traveling with them, they won't be alone, and our company has the ambition to try and propose a home for them to feel, you know, closer to their planet. Okay. And now we move from habitat to rovers.
Okay, thank you. So today I plan to present 2 projects on field trials, robotic field trials, but I think we are running out of time, but that's good lessons learned for field trials as well. It's good to have a schedule, but most likely you will screw it up at the very beginning, so be flexible. So let's skip the first slides. End of last year, we've been to Morocco for 4 weeks, trying to validate 5 other projects as part of a European project, as part of the Horizon 2020 Paraspera activities. And our job was to validate in Morocco mainly the autonomy and the sensor fusion projects. Our project was led by GMV, and the field trials mainly organized by DFKA. They brought their Sherpa rover, and as we have been responsible for the sensor fusion, we brought our own sensor box, mounted it on the rover. And when you do such field trials, try to keep on testing until the very end. Use every single minute. It's really a unique chance. And as everybody wants to use the rover, we decided to set up a second manual handheld unit so we could keep on recording data in parallel until the very end. So basically we've been in the Al Food area, that's in the middle of nowhere, close to the border to Algeria, but it doesn't mean that you have got to suffer. If you've got happy people, you will get good technical results as well. So with the help of Ibn Battuta Center, we could set up a quite nice outpost in the middle of nowhere, even sleeping facilities, water toilets, everything you need out there. Of course, we had some nice hotel nearby with a swimming pool, a restaurant, but on-site facilities really help you with your work. The main two challenges were to test the autonomy framework and the sensor fusion, and in the end we could manage to do a 1.4 kilometer autonomous drive in this really Mars-like environment. When I think about Mars, I've got such an environment in mind. So for Mars analog, go to Morocco. That's a great place. And one of the great things about the food area is that you will find everything you need for robotics. Very flat areas, sand dunes, steep cliffs, huge boulders. Everything you need for robotics you will find there. But when we are talking about moon analog, like for our robotics project, it was about exploration of extreme environments together with the deep sea people. There are better places to go to. So 2 years ago, we first asked the scientists, what would you like to do in case you could go back to moon? And they immediately came up with the idea of redoing the seismic network experiments as already done during the Apollo mission, but they could not place the seismometers that precisely. So we tried to do it better with the help of some rovers. So we had to set up 2 seismic networks, but it's better to start with a movie. So in the beginning, the rover did not know anything about its environment. It's about 2,600 meters on Mount Etna. So the rover had to set up its own map of its environment, find a place, find a lander, find a safe path to drive towards the lander, localize the seismometer inside that box, grasp it, place it on the carrier, and then safely drive to the final point to deploy it carefully. And that's really not an easy task because you've got to place it well aligned with gravity, well aligned with north-south direction, and you need a very good contact surface to measure the seismic activities on Etna. I think we will skip the rest of the video. Okay, but when you have to face such problems, you really have to be prepared for the unexpected. There's a huge list of challenges, and I just want to pick out one. For me, the funniest of all the different challenges, we use a black and white pattern to localize objects, the April tags. We were afraid of shadows, of bright sunlight, of dust, but that was no problem at all. But for some strange reason, up there on Mount Etna, there's nothing, but from time to time, there are heaps of ladybugs. And when your April tag is covered with ladybugs, it's not only black and white, now you've got a black, white, and red pattern, and your robot will fail. So to be successful, get rid of the ladybugs and be prepared for the unexpected. And now I think we are ready for our next step, and I think now it's time to go for a team of robots working together. Each of them can contribute with its own unique skills. And so next year, we plan to go back to Etna in June, July for another 4 weeks to demonstrate that using a team of robots can really help us to solve more complicated tasks. Okay.
Thank you to everyone for this interesting contribution. We are a little bit in the lead, but there is time for a couple of questions. If someone has some questions about.
Hi. One question. In a couple of years, probably Moon Village, project for the Moon Village will be presented. Maybe it will be developed, and then there will this ultimate analog habitat probably will be created. So my question to Barbara Imhoff, if you were to decide where this ultimate analog should be placed, in Antarctic or maybe underwater?
Hello? Okay. Yeah, that's a good question. I wouldn't. I think you really have to decide what you want to test and what you want to find out. So the opportunities or the advantages of underwater is really that you have a strong sense of isolation, which you have in Antarctica as well. You have, maybe you can better simulate how to suit up. So when you go for an EVA, it's probably more similar to a space mission, you know, because you have to, you know, put all the oxygen and so on. You have, you can actually simulate 1/6 gravity, which we hardly know anything about. You know, how do we move? How do we live in 1/6 gravity? We see from videos from the Apollo missions that it's not that easy. Probably, well, underwater I think is a good, I think would be a good lunar analog. I wouldn't dismiss Antarctica immediately just because you have already established infrastructure there which you can use and utilize, which is also an important point when you look at operations and logistics. So I think you really have to analyze which is the best environment, what you want to test, what the outcome should be.
Another question from Professor Foy.
Yeah, it was nice to have this panel with a diversity of experience, the one from Mars IT, Bob the Brain, which really date long and has formed a large number of explorers, scientists, engineers, and also human factor studies, but also to have the industry from the space station experience, space architect, and this will now to try to federate all this information. So we need to develop also a method where first publish the results, like we did from MDRS and others, and try to make systematic database. But my question is also there are other initiatives. For instance, in Hawaii we have put building of the ICs experience. We have now a program with the International Moon-Based Alliance that we offer. We have a number of campaigns we planned all year long where we can train young and less young people to live on the moon for 2 weeks. So please come to us. But also I was wanted to make a question based on the industry experience and space station experience on operation. Could we get some of the tools that are being used for planning space station, maybe simpler tools, and start to apply them for a mode where we'd have also partial autonomy? So are there some tools that are open source that could be made available, and then we could compare what we do in the different analog situations?
Yeah. Thanks, Bernard. First of all, let me tell you that there are so many building blocks needed to make an exploration mission a reality that, in fact, also connected to the previous question, I believe that all the terrestrial analogues will provide complementary information, and you may select one versus another one with respect to the specific building block or technology that you want to demonstrate before. As for the operation story, that is a very interesting question. The space station itself can be an analog to prepare the astronaut to operate in other locations. And in fact, there are activities ongoing. Also, for example, from the space station, you could teleoperate robotic means on the lunar surface. And you know perfectly that there are projects that we are carrying on for ESA to test and experience these operations, maybe with a time delay to simulate the delay that will be, for example, between Earth and people and rovers working on the moon, or even worse, on Mars. So we are doing that the best we can. We went to Antarctica also. I believe that what we have to do is to use all the possible locations to test the crew that will then experience in a very autonomous way, not because they want to do that, but because of the distance, They will have to carry on activities that, as Barbara said before, maybe were never planned or expected. So the unknown, we need to how can I say, to educate the crew and even to educate the robotic means to be as much autonomous as possible. This is the importance of terrestrial analogues for me.
Yeah, I'd like to speak to that. The space station certainly is an excellent analog to a trans-Mars spacecraft, assuming that craft is done in zero gravity. But the practicality of that needs to be put to the test. And I would recommend, okay, and the Mars Society would be delighted to collaborate with NASA or ESA in a mission of this kind, that we do a full Mars analog mission where they spend 6 months on the space station and then a substantial time, doesn't have to be a full year, at our station doing field exploration, and then another 6 months in the station. Because you're going to discover there's an issue here, because field exploration is a physical activity. Hiking around in a spacesuit doing fossil hunting is a very physical activity. And while the exercise program in the space station is sufficient to avoid severe health effects from deconditioning from zero gravity, I believe that it is not sufficient to ensure a highly effective crew member to do field exploration on the surface of Mars. And I think that we need to investigate this to know whether we really can go to Mars in zero gravity, or we need to be looking into artificial gravity spacecraft. So let's start simulating complete Mars missions end to end, including the spaceflight portion, the surface exploration portion, and then a spaceflight portion.
Okay. Other questions? We have just, this is just last question, I think, because we are in the lead.
Okay, so I think you guys did a lot of groundwork to build your mock-ups and have it all available for the public. Are there any standards that you guys are using that will help simulate directly with how space operations should be?
Yes, if I can join this question. This was my question. That is, everyone who makes experimentation on analogues makes a single experiment. Do you think that it's possible to arrive to a standardization? We have standards on ISS, we have standards on other space research activities. It's difficult to make standards for analogues. If it's possible or not in the future for you.
Well, what we did is we used the type of procedures which one would write for the ISS to actually conduct then the simulation mission. So the procedures and the way the actual simulation was conducted was very similar to the ISS. And so this is probably where it's easy to include similarities and the standards which already exist.
This is also a problem we identified when we were having the meetings of the analog work group. And that's why we propose the tighter cooperation, because we don't want to be reinventing the wheel again and again. We need to all get together, identify the problems, see what the standards should be, regulations, principles of operation, etc. And that's why this consortium has been proposed, just to make sure that we all work together to get it right.
Okay. I think that's all. Just the last questions is really the last question.
Yeah, stand up.
Yeah, stand up.
Thank you, everyone. I think it's a brilliant presentation. I know, well, we all know that there are several facilities that have been built all over those years, and these have been performing several types of simulation, but thinking a little bit forward on a more sustainable activity of humans in celestial body, the Moon and Mars, I don't know if there has been any kind of collaboration between facilities to do a different type of simulation in which you can actually have two different crews and two different sites on the world that actually start to communicate within each other and try to mitigate some of the dependency that they have on the communication back to Earth. I think that from a Mars-specific one, it's a capability that starts to be studied, because relying on all the communication from Mars to Earth for support will be highly complicated. So have there been any initiative to do a simultaneously multi-site simulation to test how they can support to each other?
Yeah, I can answer briefly. With the Meteoron activity, people were located in ESTEC, and there was an astronaut on board the space station, and they were really simulating what could happen between an astronaut sitting on board the Gateway and an astronaut operating on the lunar surface. So that is happening right now.
I think in any proper analog simulation, you have a mission control and you have a time delay depending on, if you simulate Mars or Moon. So I think this is a standard procedure.
Yeah, I support that. The key collaboration that needs to be developed is between, well, not mission control, but mission support and the crew on Mars. In other words, we have to develop an art of telescience. Okay, you've heard of telemedicine, the doctor in the outback being supported by the experts in Mount Sinai Hospital on doing a heart transplant. Well, we're going to have to do science that way, because you might have a crew of 6 on Mars, including a couple of generalist scientists, field geologists, but a back room on Earth with all the specialists in it. And to develop a kind of collaboration between the field on Mars and the back room on Earth, and also other assets, orbital satellites, robots, etc. This is an art of combined operations, but in particular, collaboration between a few scientists on Mars acting as a spearhead for a much larger group back on Earth, who aren't going to control them the way we control robots, but are going to advise them and collaborate with them. It's not how people do field science on Earth now. We have to develop that art. Telescience.
So what we've done, for example, on Etna, we had a control center down in Catania, about 35 kilometers away, and from there they could supervise the robots, check the quality of the signals, and the robots have been mainly operating autonomous, but the scientists have been far away in the control center on the coast.
Yes, I can add to this also. For example, in our case, we are investigating the use of virtual reality to control by remote some mission activities. And also to add to what has said already Barbara, generally the ones who make analog missions are linked together, and in the network of the Mars Society, I think many experiments have been made of connection between different crew missions. That's all for this event. The discussion could be very, very long, but really we are in the lead, and if you have other questions, obviously you can ask directly after the event to the people of the panel, that I thank a lot for their interesting contribute to this discussion. Have a nice day.